Hello, everyone. Welcome back. Welcome back. We're finally getting back into it. One of the cameras is drifting low. Should have noticed that. Oh well, we'll get to it. Oh, we're going to be getting back to our game dev project. But before we do, let's check in with the kitties. We do have, let's see. Oof. Well, Sammy was on my shoulder. She is no longer. Sherbet is on my headrest, briefly. Let's see. Sky on the bed, Mason on the bed. I think Ember might be up in the tree. Hey there, Oto. Welcome. I need to put out more food for them. Oh boy, our first break is going to be busy. Oh, good times, good times. We're just getting into some programming on our game, Oto. Just getting started. I think it's broken right now. In fact, I'm pretty sure it's broken. But let's verify. Just gonna get that out of the way there. Okay, and we'll go to our shader. We're not storing to the image, so that should be okay. Run program. Oh, well, that's a further problem. Get the device, load the shader file, get... Oh, I think I may have moved that. Okay, that's why. So we're in services, flows. Hey there, Key. Welcome. Flows, shaders. Okay, that should work now. Been trying to reorganize again. Okay. So basic function, for those that recall, we are trying to get it set up so that we can have floor maps that enemies can move through. Technically, there is a floor map present, you just can't see it. But you can see their movement blockading there. It's largely because it's broken right now. But we'll get there. We'll get there. Let me see if I can pull that up. Drivers, data, flow, floor flow, EXR. I love some deep string music. So this is the flow pattern. Let me see if I can get an idea here. Yeah, everything is essentially pointing back up this way currently. Negative numbers show up as black when you look at them through a basic editor. But they're all pointing to the upper left corner. It is opposed by the base flow of movement. But we'll get there. We'll get there. So, part of the problem we were having last time was that we were getting an access violation during this. And what I discovered is that it all boils down to this part, where in the shader we are editing the output image. Apparently, if you do that a lot, very fast, across multiple processors in the GPU, it don't like it. And there's the chance on smaller ones, but it will happen on bigger ones that it will cause an access violation. So we need to redo that. We're going to be changing it, hopefully, today to just set to an array. Almost certainly, Oto. I'm guessing that there's something in the background as far as the memory for a texture in Godot's variation of GLSL. That once you, like, if you're in the process of messing with it, you can't mess with it at the exact same moment. Or something similar. But long story short, it exploded. So we're going to be changing this little guy here to just be an array. It technically allows this to just be an array, the floor texture, but there's actual practicality to that one for it to be a visual element. The flow doesn't need to be a visual element. I will have code to convert it over to one. Even at large sizes, it's not too bad to iterate over all of the pixels in even like a 4K texture and fill them back in. Is it cheap? No, but that would only be for debugging purposes and once per floor. Oh, no, we won't be doing that every frame. This is a compute shader. This is largely a one-and-done operation. Why are we doing it in a shader, if because of that? Because I want to. This is a bit of a learning operation. We do have a compute shader for all of our collision that we do every frame. This one's functional. This one is largely just because, and I don't want the initial load when new mods are socketed in to be abysmally slow. And this lets it speed up real quick as far as generating these flows. Will the flows work? I actually have doubts about my idea as far as their function, but it's something that we can tweak very easily. For reference, what this does is it takes in an image and it looks for any non-alpha 0 stuff, anything that actually has visible content on it. And it's going to consider that movable space. And it will output effectively a pattern for how to avoid the walls. We pair that with another bit of movement that says this is where your target is. Like, if this is the 0, this is how you get to it. That's largely mechanical. That's just from your current vector to this one, but we may simplify it a great deal so that instead of constantly creating unit vectors of various types, we're just directly consulting an array and saying, this is exactly how you move in this particular unit vector. Extraneous don't need to do it, but we're doing it. So yes, I did find out that I can use EXR formats that are composed of, 4-digit color vectors, vector 4s that have half floats in them that will accept negative values, but that's becoming debugged now. For reference, this is the actual flow to center image. Loading. This is what flow to center looks like. Like I mentioned, The black areas have only negative numbers. Anything that is visible has positive numbers, but each of them can be great big values. They can exceed 1, whereas normal color formats are generally like 0 to 1 in their color values. This can be whatever we want, within the limits of a half float. But yeah, okay. So we need to set this one up differently, which will be a standard 430. It will have a float array in it, and we will pair that with our image params width and height values to allow us to convert the positions into a one-dimensional array. That is Krita, Krita. I believe there's a free version and a premium version. That the premium version is largely like to fund it in for some little perks. I don't know if they've changed those perks to be available anyway. But it's a pretty good editor that isn't like Photoshop expensive, you know? And the format is EXR. Hello, Oro. Welcome. Okay. So we need to set up this the buffer differently. That's our input buffer. We need to make new buffers for each individual one when we are generating it. There's our pipeline. There is the input texture. Well, welcome back. So this is where we're setting up the different textures. Names escape me. Names escape me. Is it 10 Rosani or is it Oro? 1 Oro. Looks actually like 10 now that I look at it. Blue on black. My eyes aren't great. So this is our output texture. We won't be doing this part though. We're going to be setting up the uniform differently. We're going to change you. Okay, 10. And this is a data type uniform. We can't use the regular uniform for that, right? Okay, we are creating that buffer up here. I'm refreshing my memory on this. Last week has not been great for mental state and thus, well, coding memory retention here. We create the buffer, but we're going to need to load that uniform into the buffer. Here we go. It is a storage buffer. Yes. Rotating wrist. Crack and pop. Between gamepad-based video games in my youth, computers in my youth, and computers professionally, I have been dancing on the edge of RSI for pretty much most of my life at this point. So remembering to do proper arm rotations on the regular is kind of important. At least the surgery, if that ends up needing to be corrected surgically, is not as gruesome as it used to be. Though there was somebody, I recall there was an esports fellow, either something like StarCraft or, your Dota / League of Legends, something with a crazy high actions per minute kind of thing. They ended up letting it go untreated for a while, and the surgical scar for it went from the base of their palm all the way down their arm up to their shoulder. Just this gouged scar from the surgery. You can get like carpal tunnel surgery that's just a tiny incision now. But I have also seen it previously when it was unpleasant and not as effective. So I'm leery of that, trying to avoid it. Okay, so we're going to change you to a storage buffer. Binding 1. Now, we're not going to add the floor flow ID for this. The floor flow goes away. This whole chunk goes away, which will create that problem. This is where we're going to add the ID for the buffer, though. Which we need to create. The buffer we can technically reuse. Oh. No, we need to recreate it each time. Yeah. So the params buffer, oh, we're keeping the output buffer around. It's our output value. Okay, no, we're not keeping the output buffer or the input texture buffer around, because that needs to be recreated to the appropriate size every time. Have I played Hollow Knight? I have played the first Hollow Knight. Never really got close to completing the first Hollow Knight. I love the art. The atmosphere is kind of neat. Very cute art with the muted kind of heavily gray palette with bright strokes through it is always kind of nice. But very cute. I'm just not a precision platformer person anymore. If for no other reason than that's really suited to like game pads. And do. I have these, but I never remember to use them. This one I use in screen caps a lot. It is appropriate to puzzle games and coding. When I remember to. The output buffer needs to be changed to be local, because we're only... No, we should actually keep it around. We need to keep this around, because we need to get it back. Input params buffer we keep around because it doesn't change in size. It's always the size of a single input param structure. So we don't need to remake it. Right there, the byte's length. It is one of these in size, which technically means it's one of these in size plus a uint. But because we don't have like 5 variables, we don't need to worry about that. But in any event, Black Sniper, welcome. We are working on our game project, and right now we're working on the shader that converts a walkable surface image into a navigation map for the swarm of enemies that will be generated. In theory. Oh, let's see here. Swarm of people coming in on the Twitch side. We got a raid, so... Hey there, Lunas and company. Hey, Lunas and Raiders. This is Visual Studio. Yes, we are working on our game project. At the moment, we're working on a compute shaders input. Yeah, Visual Studio, using C#. We're using the Godot engine, and we're working on this shader. Trying to noodle this out. This entire project lives in my head, for the most part. So sometimes it slows down. And thank you for the follows over there on the Twitch side, and welcome to all the raiders. Sorry if I don't get all of the individual names. And it sounds like Key orchestrated this. So. I like Visual Studio. When I started this project, I was poking at what's it called? Visual Studio Code. But the user interface for it was just short of offensive to me, given that I have, like, my whole coding life really kicked off with Visual Studio way back. And Visual Studio Code has a great many similarities, but there are differences that are inexplicable. Just like, but why? The Solution Explorer is oddly different in places. Hotkeys and options are strangely different. It has that we wanted this, but we had a completely different team make it, and say, kind of like that thing. Don't do that. I mean, for this project, we technically started trying to just do all GD script. But for those joining, I am newtmechanist. I am the nanotype game vtuber. We do some gaming, but lately it's been mostly our game coding sessions. A majority of the coding happens during the stream, but as we go along, I increasingly need to do more and more research and like refinement offline, so that our streams don't bog down too much. A cat has approached my feet. Since we do have new folks, let's check in with the kitties here. Still need to correct the tree camera, but happily none of them are on it. let's see. We have... Okay, Mason and Sky still on the bed. Sky has shifted to the blanket. Sammy is at her spot over on the shelf. Not quite glaring at me, but she's looking over here. You can see Ember over in the play area. Let's zoom in on that. Oop. That is Ember kind of in the top there. She is tiny. She's my second oldest cat, and she is by far the smallest. The black square is a TV showing, like, birds and stuff. And Ember is one of the two that is very passionate about trying to get those birds. But we generally have the camera over here on the bed. Since we can get... We have actually had all of them on this camera before, but 2 to 3 is pretty common. It is the nap time area. Brain. Okay, so we still need to keep it around, but we're going to make a new one in this. So we need to create the buffer. So we're going to do a buffer create, and we do it at the length that we've got. What that will mean is that we need our output texture to be created here. We will get that output again, so we don't need to worry about... We should have it as the same size. This is all a in-process operation, and these are all local. So it will be happening synchronously. No, we'll create it locally. We'll create it locally. All right. Float array. Is floor width times floor height. One thing that this stream has been a fun little experience in is that the IntelliSense that I learned over my entire life here has, in the past few years, gone in a weird direction. And to me, it's kind of clear that they've wired in some of their AI logic into it, because it will suggest things that are not just like finish the function name kind of stuff. And some of the suggestions make no sense at all. Like, either that's definitely not what I would want given the rest of the code that I have written in all of this stuff, or that can't compile. Stuff I've seen things like, hey, this float array is equal to new vector 4. No. That won't do. I mean, technically it probably would do. Just you would not do. Storage buffer. Our output array is not the RID for that. It is going to be a buffer update. It's not really a buffer update that we're doing for that one. All right, let's look at our collision manager and verify how we've got that. Still doing buffer updates to it. That should be fine. Where we create it, the size of it and what we're loading in, size of it in bytes. We should make it a byte array as a result. It wants byte arrays, by the way. We will interact with it as if it is a float array, and there is some sorcery we're going to do for that. Yeah, we're just going to do buffer updates on it. So we create the buffer of the appropriate type, then we do buffer update. All right, Flames. Thanks for swinging by. Thanks for joining the raid. Ember has jumped onto my shoulder, so my code interaction capabilities are impeded because she will need constant attention or she will stand up. Welcome back, Oto. Okay, so this should be bytes. Byte times size of float. We will submit it and then we get it back. So output bytes here for the name. So we're setting up a byte array to be what we pass in to act as the output value and what we will load the output value back into. This buffer is to create the location that we are going to write to. And we will use that to get our information back. So we need to create our buffer here. Don't have a create buffer, but I think we should get a create buffer. Create buffer is simple enough, but this lets us take the data and make the buffer from it. So we'll just nab you. Okay. Say RID, it should be, so RIDs are resource identifiers in Godot. Put bytes, then we have our uniform, and we're going to put our output buffer in it. That, and we don't need to buffer update it because we are just creating that. There's no actual data being stuffed in there. We set up our uniform. We are passing in our output array, our image params, our input image. Again, we submit, we sync. This is normally not good practice because this will force the GPU to begin calculation and then immediately sync back up with the CPU. But we are doing this at startup. This is This is technically a one-off operation that will only be done if it hasn't been done before, or if the data that it was done on gets updated. Okay, we are not doing texture get data for this. Let's break this apart so we can see more of the pieces. We can't run it right now. It will super break. And since we're dealing with shaders, we really don't want it to super break. The first time I worked on shaders in this set of streams, we managed to blue screen twice. Once during stream and once after stream. 2 separate occasions. It's not going to be this. Go to our collision manager, and we're going to do... On world steps done is when we're starting it, and then on game step should be where we check it. Yes, okay, so we get the data. We are going to do a buffer get data on that buffer. This is our output buffer. So now we have our output bytes. We're still going to have our... This part's going to be different. This needs to be adjusted. And we can short circuit some of this. We will not be doing it as ij. This will be as an operation here. So I is each row. So that will be I times floor width. It's ij. Okay. We will be getting the data during this step. Okay, it's not floats. We're not doing floats. It's vector 4s. Ooh, okay, we're gonna have to do memory marshalling here. Not casting. Size of. Sky. What? What? All right, I'm going to be back real quick. I got to check on a couple of things, and Sky is going to wreak havoc if I don't fill the food dishes. So one moment. Did I get that right for the camera? Yeah, okay. Might have to tighten the screw on that camera. I'll have to also clean the lint out of that. The cat carpeting has grown dense in the back corner. They were all very hungry. Sherbet and Molly are chow hounds. If they're even a little hungry, they'll come over immediately when the dish is poured there. You can see Sky's shadow at the top center of the play area there. Oh, he darted in. Let's see if he does his normal thing. Okay, you see how he grabbed some kibble and backed up? What Sky will do is he'll grab a couple of kibbles, he'll back away from the other cats, and he will shake and crush the kibble. Like he's making sure the kibble is dead before he eats it, which causes him to make an incredible mess. But anyhow. Okay, so we have... This is the size of vector 4s now. We're going to create a buffer from that. They are all sweethearts in their own way. In addition to kind of a mini hiatus last week, part of it was getting a majority of them some updated vaccines. And that operation ran the gamut of difficulty. Sky went along, but he's really put out by it. Like he's unhappy when he has to travel by car. He's normally very social, but it makes him very scared. Sammy, well, Mason is put out by it, but for the most part, it just makes him very anxious. All of the cats are spayed and neutered, Odo. They're all also entirely indoor cats. Maximum health and safety. Let's see. Sammy really doesn't like getting put in the bin. Sammy will try to destroy any carrier she's put in to try to escape. The first time that I put her in a plastic carrier, there were claw slashes all over the inside of it. She fights hard to try to get out. But she tends to, like, she's upset by it, but it's largely she doesn't want to be in the box. Sherbet goes into full panic mode and is the hardest to get into a carrier. With Sherbet, it tends to be a matter of blocking off all escape paths and wearing him down until he gets so tired he makes a mistake. And that stresses him out. The car ride stresses him out. I try to minimize the amount of times that I have to do that with him. Because he reacts real bad to it. So create that buffer, and then when we get it, we are going to marshal it over into another shape. Should be in here. All right, memory marshal.cast. So it's not going to be an array, it's going to be a span of vector 4s. What this does... Hey there, Lunar. Let's see. Did you add the cluster truck style parkour game where you're running away from an unrealistically slow explosion in an Acme factory yet? I haven't decided on all of the different visuals for it, but I do plan to have some sort of you have to keep moving steadily kind of operation in the game that will take various forms. Okay, so we need a span and we need memory marshal cast here. Okay, so what this does, we have these output bytes. We have a byte array that is going to contain the data that we have here. It is sized up and ready to hold this information. When we memory marshal cast it, we're not creating a new array that we're going to put the data into in the form of vectors. We're saying, treat this array, the layout of this array, as if it were a span of vector 4s. Take that same data structure and kind of lay this over top of it. This limits the number of array creations we're doing. Now, can I short circuit this kind of thing to further limit the number of creations we're doing? Yes. Are we going to? Not yet. Okay, so we get this. Then we are going to say, we're going to put this as output vectors. Should be able to use a vector 4 as one of its initializers, right? Too long, int, string. You can't. Why would you not? They need to be vector 4s because the shader knows what those are. No, okay. We say output vectors. And that will be I times floor width plus j. No. That's the other way around. No, that's okay. So this is setting it up in columns, is how we're setting it up, but that's okay. As long as we're consistent about this pattern. I gave you food. I did. The food dishes I use for them avoid the problem of there's food in the dish, but they don't want to take it. With cat food bowls, you want them to be shallow so that their whiskers don't have to brush the tall edges of a bowl to get to the food. That's why when it's crammed up against the side, they don't try to get it when it's a tall bowl, because that'll twist their whiskers back to do it. And that makes them uncomfortable. It's irritating to them and stressful. Hello, Ember. Yes. Typing around cat. So we're making a color out of this vector. And we're setting it accordingly. So then we need the corresponding values in the shader. That would be the result. For one, we need to change this. Come on, baby. Come on. We need to make up your mind. I think this is the right syntax, but there's going to be other stuff that fails when we do this. But we're going to kind of step through the errors here. Testbed, flows, shaders, GLSL. $16. Is when we are declaring that. Do we need to use this notation? Oh, that is a vec4. Okay. For our flow color, it's a new vec4, getting the direction. So instead of image store, we're going to do our output vectors.data. And this will need our I and J here. It is times our width value. Image width equal to flow color. Still compiles. Okay. This is testable now. Does it break? Wait, it's just not going to work. Oh, no, here we go. Oh, I didn't create the texture. Womp womp. Need to restore some of this. Oops. Why it not do? Okay, yes, yes. It is indeed created. Because it's not that. Where did we get that before? Okay, we should just do this instead. Are we creating it elsewhere? Ah, okay. We don't want to create it from data. Height, width, bitmaps, in format. RGBAH is the EXR format. That, we're going to iterate over it. We get the vector value, we output the colors, we run this code, and it works this time. Check here, floor flow test was just updated. Wow, right on the hour. All right, these are the wall markers. It's really hard to see, but each of these will have a unit vector in them. So negative red, positive green. Now it's a matter of updating the algorithm here, because all of this space should be filled in. So the problem here is that direction might not be filled in. Here's our search value. If it's not equal 0, then we do this. Double check in Godot that it compiles. The Godot editor is to ensure that that shader compiles. The Visual Studio side does not compile that shader. This just blocks the edges, but this whole other region here. Because if we open up our data, textures, rooms, flow test here, this is the black is navigable space. So these are dead zones. These should all have information in them. So this is, we have found a wall. And we only go here if there is color in it. So we are going to fill in all of these. One divided by 0, that'll go well. Hello again, Ember. Hello. Ember is very snuggly. Okay, if the floor color has color to it, we are going to output something. It will always have an alpha channel to it. Oops. That won't actually do anything. First, we have to go here. Close that up. Close this up so that we don't get any possible lock contention going on there. Tab, data, flow. Okay. Now what we're going to do is we're going to expand that search range. Right now the search range is like 1. And what that means is whenever there is floor territory, how far do we look before we'll make adjustments? Changing the search range is a big deal computationally. It's each pixel will look around it in the search range to locate a possible wall. So when we're messing with search range, we need to be real cognizant of that. We're going to do twice the average size of an entity here, or at least of their hitboxes. So that'll be 30. No, it'll be 16 because the base radius is 8. This will be much slower. If we get an access violation, we know it's cut itself off. I don't know if that actually saved properly. Shouldn't have needed a recompile. There we go. So the border there is, again, the direction you move to get away from the wall. So let's actually run this. So we will need to account for dead space in that they don't move if it's in dead space. That is super weird what just happened. Because they're still around. Interim save. I don't use this as an actual, like, push to production at this time. These are essentially save states. Yeah, it does have that no clipped through the floor kind of vibe to it. Move on grid. It's going to say get floor flow. We need to make sure that the floor flow is output. We have an image. add it, and then we normalize it out here. This is already weird. The projectiles are being emitted properly. Not a number. How is that not a number? As an integer. Well, that's certainly going to cause a problem. Yeah, that's going to make it go completely haywire. Okay. So why is not number? So these initially emit just fine because they have nothing to home in on. As soon as an enemy exists, the first mouse will find that and thus do move on grid here. Okay. It is within range. Pixel head. Oh. It's going to return a color. And that won't work for negatives. Okay. We don't want it to be an image. There's no reason for it to be an image. So this is where things start to get fiddly as far as refactoring. So it is the room that is going to have... The current room is the thing that's going to have the floor flow to it. And the current room... Well, the current room will have a composite of floor flows because it's possible that we're going to stick multiple of them together. That makes it array space. As long as we keep a reference to it, that memory stays allocated. So we're okay there. We don't want to get the whole floor flow. What we would want is that the flow generator makes it. Then we can have something manage that. We'll move it into floor flow manager, which will keep them around and act as a reference source. But for now, we'll put them in... we're We're going to put it in the generator because that's what code is using. Okay, we don't need to remake the things over and over. And we're not actually going to create an image out of this. We're going to create a raw data file. For the time being, it'll be an image. Actually, let's run to here. Okay, we definitely cannot use color. We're getting not a number out of that. So we don't want to be consulting the image. The image is purely for saving purposes. Noted. Vector 4. We're using output vectors so that it mirrors this. Width and height. Width, height, height. Width, height. Height. Okay. We're removing the stuff that we... No. now. We might as well use... We might as well pass that in because we've already marshaled it. We want to keep those bytes around. We want to keep the span around. Vectors. Also gets a file path, but create floor flow shouldn't need a file path. But we're going to keep one. Because it might need it. We're testing. We run it again. Oh, hey there, Aya. Sorry, or Yopi. Sorry. As far as progress, we're working on the way enemies move around right now. So it's kind of invisible, but... Okay, still saving the file properly. So then we're also going to store that flow off. For now, we're going to put it here. Did dictionary string span of 4. Not be a reference structure. Tell me more. Yes, 9244. I don't know how expensive the cast is, but we could use... and just store off the bytes and cast them when we need them. Okay, so flows. Want our texture key. Okay, so we store off the output paired with the key. This creates a chunk of memory flowing around, but that's okay. So then when we need to get that, okay, so then a result to new 4. That'll by default. We only need that elsewhere. We're going to return result. Oh boy. We need to know the boundaries of it as well. So it can't just be that. Okay. 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 Science, graph span, vector 4. Nope. All right. We can still do this. This is still fine. Everything's okay. Is equal to image width. So what we're doing here is we're storing off all of the metadata that we'll need. Fine. It'll be an int. Not going to call this one anymore. That'll cause problems. Well, we are going to call this. We're going to completely restructure it, though. Doesn't contain the key for key. So then we create the file path here. Okay, so if we don't find the texture that we're looking for, and this key might be something else. This key is probably going to be the room key and not the textures, ultimately. Okay, for now, this is going, let's see, if... Can I pass? See, it says, oh, well, it'd be flow width, flow height, right? Why? Why is that what you would think? As integer explicit cast. If this be at least 0, and it's less than flow is equal to. See, this can fail right here. Because if it does not actually save a result, that's null. This will explode. That's kind of okay right now. And that. And y height. Then put that there. That's not actually what we want. Copy this, and that's going to be dot flow x times flow width plus y. Oh, or vectors. Or floor dot flow. Okay, so we get the flow value here. We are directly creating the floor flow there. So we're never going to call get floor flow. Instead, when we move on grid, this should break now. To definition, That's not what we want. Same with this, is we won't be using get flow to center. We'll store it off differently, but we'll leave that alone for now. Should still have another problem. Okay, right here. So we're not going to use floor flow here. So this whole chunk changes. We're keeping this because I wanted to get this value here. So this chunk changes. We are going to say at dot flow value that, and we need magic string, but that's not actually what we're going to be using. So there's our flow vector. This is also not how I want to use it. If it is not 0, if it has any data, that's what we're going to deal with it as here. And hello, Jamel. Welcome. Do that there, and we don't do that. And this will totally work. And it does not totally work. I wonder if the cast is not functioning the way that we want it to. So we clearly have some sort of error in our callback here. So initially it does not contain the key. So we're going to create it. We get an exception. Index was out of bounds. It's going again. About 3 seconds in. How long have I been coding in C#? A year or two now? Started coding in C# like extensively for this project. Cursor. Hey there, Alkaline. And company. Welcome, everybody. Welcome, Raiders. Save flow to image explodes. We are getting something bigger than we have in array space. Somewhere in here, it's not liking it. Should be I times width plus j. Every width segment has j height segments in it. Again, we're creating columns, but as long as we're consistent. That could mean that vectors doesn't have any values in it. Learning programming languages can be really straightforward. A lot of the nuance is in, the particular functions in some of the syntax. The syntax comes quickly, the functions come with repetition and experience. Okay, so vectors. Vectors is empty. It has nothing. Well, that'll create a problem. We don't want it in save flow to image. We want it to be here. Have nothing in output bytes. Okay. Any advice to help on the journey? Make use of the internet. When I initially learned to code, that wasn't really an option. And I can tell you it grossly accelerates your ability to find solutions. Now, look at multiple sources, because just because Stack Overflow says it will work or that that's the right way to do it doesn't mean that's actually the best way to do it for your implementation. Just because it was readily available doesn't mean it's the right thing to do at the time. But you will accelerate your learning greatly by leveraging the world's existing knowledge with verification, as well as just doing stuff. Like, try things, make things, code stuff. Okay, 16 makes sense. Output bytes was created. Oh no. Wait a minute. That's why. That's why. Wrong buffer. Wrong buffer. Wait, no, right buffer. Why did I think wrong buffer? The right buffer. Bytes exists. Bytes does not exist. Which means span does not exist, which means we have a problem. Coming back with nothing is the trick. Using width I times width plus j, where we should have something. Binding 1. It's a write-only buffer. We're just putting stuff in it. 430, binding 1, set 0. Okay. A lot of this stuff I don't need to keep global. Create a uniform set with array uniform. Add the output buffer. Shouldn't need to update the buffer. Those cats are mine, yes. Oh, we've got 4. Let's zoom in on that. We have 4 on camera. All right, let's see. Lower left is Molly on the leftmost, then Sherbet. Then right on the big Squishmallow pillow is Sammy. And up above them all is Mason. Then Ember is top center across from my keyboard. And Sky is the big fluff ball up in the cat tree square there. Rectangle. There are 6 in total. Okay, so the buffer is not... the buffer does not create anything. Call create buffer. We go to definition. We are giving it data. This uniform. as data. We are going to new int just gonna new 1003, and it explodes. It's not that, it's that the result that we're getting back is broken. Now, it could be that the shader is failing, but that would be exceptionally odd. Because we were saving before. Oh, we were saving before we were dealing with some of this, but so we know that this is properly populated before we call get data. This output buffer has a problem. Like, it won't get to here. It will not save the file. Actually, real quickly. Close. No compile errors with the shader, so we didn't accidentally change something. So why are the output bytes resulting in nothing when we call that buffer? Storage buffer. We add the ID to it. Buffer, it's not a sampler, it's not a uniform buffer, it is a storage buffer. Just like the one down here. The one further up, because we create that and keep it around once. Should free it once we're done with it as well. That'll leak like crazy otherwise. Well, thanks for swinging through, Jamel. I appreciate it. Just a wild guess there. Is it perhaps that we can still move, everything's okay up until we invoke that code. In which case it starts to infinite loop hard on this portion. And this will cause a problem eventually. It'll cause a leak that'll eat up memory space available to us. Yeah, it's airing out on that constantly because the data that results from the call is still 0. It's nothing. So we submitted it, we synced it. There's something wrong with the way that we're doing the binding here. If we remove the write only, I mean, it is write only. Yeah, you can see the leak happening here because we're just creating images back to back to back to back real quick. It's not that they're lingering, but we are instantiating them within the Godot process and never letting them go. Which those leaks are going to be something that we're going to have to hunt for and find, but finding one. Telling it we're passing in an array of vector 4s. And we do have that data passed in. Each one in the segment. If we search through it and say if the floor flow is 1, created that texture. We passed it in. And we should be able to get all the way down through the rest of this. So again, output bytes has a ton of space in it. Create the array uniform, output array uniform, which is storage buffer to binding 1. This was to binding 0. And then binding 2 is the parameters for it. There. Directed to read only. Going to be that dumb. Is it a syntax error that the shader compile didn't catch? Nope, same problem. We don't have to do anything special in the collision one. Get buffer data for the buffer. So we sync, we get that buffer's data. Why does that not work? Let's see what that returns. Maybe there's just some sort of anomaly here. Nope, returns absolutely nothing. check something real quick here. Async, we are submitting. Found as a storage buffer. Okay, maybe the buffer size is incorrect. That. If we will properly create the output buffer here. Is a storage buffer. Call sync, then we get the data, right? Submit, sync, get the data. Should still be the exact same problem doing this. I know I tried this before. Need to remove the delay on that guy's behavior so we can get right to this test. We have called sync. And it's purged. This is indeed puzzling. Think. I think... Okay, quick break, and then we're going to keep poking this. Be right back. And we're back. So this is the necessary sequence to get the compute shader to fire. We know that that is the case. When it was an image, it was coming back with results. We know that we were getting results otherwise. So let's just not do the save to image for a moment. Which shouldn't matter at all. How? I mean, we're never using it up to that point, but... Yeah, output bytes is still nothing. It's non-functional when we do that. So it should be as soon as they get in here, I think right now they should be within range. But they're never reaching that point. Like, this is never happening. Can that not happen? Touch the door. collision happens with the little red dot, you get thrown backwards. Okay, they should all be within range now. Which probably means in here we've got a problem. The flow to center. Oh, okay, we wouldn't use offset here. Okay, so we should get the same error once they cross this line or kind of in this vicinity as well. So if they pass the tiny red dot, yeah, okay, there we go. It's like the shader is just not... All right. I forgot. It's running on the Godot side gives you access to a different set of errors than on the C# side. You can do line-by-line code execution debugging on the C# side, but the Godot side is going to tell you some of the stuff that's going on here. Move on grid 83 to base flow generator 308. Flow and then into 308. Okay, so we got the result and it's failing there. Hello again, Black Sniper. $89 to $210. We're triggering this in the physics step. Maybe it doesn't like that. This is failing. Buffer update can only be called from the render thread. But I've been doing that, right? Yeah, buffer update. Buffer update. No offset. Size of it. The data. Yeah, this is going to cause problems off the get-go. Zero comma output bytes length as a uint. Wait for it. $194. $194. Okay. Okay, it's buffer update. But how is it buffer update becomes the question. Never seen any examples that use that. They haven't needed it. Because this is happening in the physics tick, just like how in the collider it's happening in the physics tick. The end of all of our steps in the physics tick and then at the start of the physics tick. Now I could have it set up so that as soon as this thing is instantiated, it runs, but we need a method for getting this data. We are going to pre-build all of this, but first we need to understand why we're getting nothing in the data. Another quick bind and submit sync. Yes. There's nothing about that sequence that is fundamentally wrong. So again, we're doing that. We're just waiting a whole frame. But this pattern should be okay. So we already know we have an issue when we're calling buffer update here. If we create the buffer with that content up here, we can dodge some of this. But we still need to buffer update it because we need different floor images. So we're having to change that value and overlay these. So this is still accurate. Create the uniform, we add to it. Create the uniform, add to it. you mean it can only be called from the render thread? This doesn't make a lot of sense. I haven't updated the Godot version, so we shouldn't be having a fundamental change here. Isn't even like this. Disarray is accurate, James. Suddenly, it doesn't want me using my rendering device methods outside of the rendering thread. But it had not needed that until now, and our collision one doesn't care about that. It's the same little guy as this one. Create local renderer. They're running at the same time, but each of them is their own rendering has their own server. Create local rendering device. They're each their own little guy. The assertion that the error is making is that either as soon as I call, it's either this one or this one. Buffer update and compute list. Actually, it's compute list begin. Create a pipeline. At each uniform, we are doing our buffer update. Then we're going to compute list begin. Bind pipeline, bind uniform set, dispatch, and submit sync. This doesn't happen in the render thread. All of this stuff happens in the physics thread. It implies that the shader is failing to run, that it's essentially a silent failure as far as the main code is concerned. If this is the case, I don't understand how we aren't immediately getting the exact same errors out of the physics thread. So there's some fundamental difference in what we're up to here. It's again, we have collisions that can happen. It just means that this one has a problem. Let's get that Godot error, and I'll try to look that one up. All right. Looking up issues. Why can that happen, though? That's what I'm doing. think that's got to be our variation, is something about the way it's being called. Time passed, game time passed. In our physics process step, and we're constantly doing that within the same general step. Processing a message, and it runs in through here. We have to do it in this general fashion. Because each one of these motions is going to be asking the room what the data is. And each room will have its own grid, which means at any time that particular grid may need to be generated. We could make this part of, if you find a room texture, for each of the textures in the room, run this code. Ugh. Oh, this one's stubborn. All of this stuff it's complaining is only able to be called on the render thread, which, again, we're not doing. If I trace it all the way back, we're in physics process. Which is in the physics thread, which should not be an actual problem, because the physics thread is, like, that is the other recommended place to put a compute shader. Is there a problem with the way that I'm making the shader? All right, we're going to see if this happens in the other spot too. That didn't do anything. So create flow to center is pretty much the same thing. Oh, no. Okay, no. I had this in a... So this is not creating the problem. There's got to be some sort of element that we're missing that is allowing this to work over here. Create the pipeline. And that's fine. Create the buffers from their data, and that's fine. We should just create the flow input buffer here. Let me take a look. James has a suggestion. Looking. Or at least a potential data point. And I limit that down. Is that something that we can cull down? Because there should only be one flow generator. But it's possible that these are being called lots and lots of times. But they're not asynchronous. Don't understand that seems related, James. Or at least it sounds related, you know? On 209. Because this is the weird thing about this is this one is getting called as well. And should be getting called before that. Yeah. Both are calling buffer update. Zero length data. This one it doesn't like. Is it because we're passing an image in? That. Temporarily do that. Just going to X this whole segment. Nope. So again, there's some weird fundamental difference going on here. As far as what's happening in this rendering process when we are creating these. Shader Collision Manager also on ready creates that. Well, that's on ready. Let's shift that around. If rendering device equals null. Okay, they're going haywire again. But it's unclear where in that process. Okay. If I had to guess, what we're getting is that when these were created, when the flow generator ended up being created, that created it in a circumstance that said it had to operate on the render thread. And we're moving that elsewhere. So we're going to run here. We know there are some other problems going on. Okay, we're getting not a numbers again. Get flow value. And it has the data in it. Okay. Get our flow position. Position that's being passed in is not a number. Well, that's super weird. Let's catch it early, because if we're getting invalid numbers, it's going to go haywire as soon as they come into existence. That's probably why they're popping out of existence. Okay, we're getting not a numbers in our vectors here. So when we get flow value, we're going to look for it there. That should be setting byte data. And over in the create call, or flow. So it starts 25555555127. Okay. We're trying to track where the data is getting wrong. And I think we're going to get into here. So now we're saying that memory that is our bytes, we want to treat that as if it is vector 4s. Which is all gibberish. Anything that got set is a mess now. Which implies it's being set incorrectly in the shader. Like, this shouldn't actually matter because we're doing it elsewhere. Like that. Now there's the implication that we have it off kilter. That the bytes that we're sending in, or the data that we're getting back, isn't the data that we want. Direction is a vector 2. So let's see, what am I experimenting with right now? Or how to articulate. Let's see if it do anything. Oh, what I did is I saved the vectors in a different fashion. but that didn't matter. So we can see that the W is getting set, but our X and Y is not. The fact that the W is getting set properly implies to me that we've got something else going on here. And we're using the Godot data types. Let's move on grid. Yeah, we're using the Godot data type, so using you at all right now. So there's something about the data that we're generating in the shader. Something about this it doesn't like. So we're going to do... We're going to ignore that direction variable entirely. And when we get the flow value, we're going to see what our results are this time. Okay, something about the variables that we are stuffing into it are wrong. Because the end result is correct. Like, our output values work. Now, you can see as soon as they hit the edges, where we would be setting data, they are pushed down and right. Anywhere that the image would be, it goes down and right. So the player is standing in one of the active areas, so they have trouble approaching. All right. So in general, it's functional, but the math that we're doing in here doesn't work. We could just keep accumulating direction, but the problem is that we don't want to put excess weight into this minus here. So there is something about repeatedly doing this that it's not liking. loading in these values is causing an issue. We remove that. We're going to slice out some lines. We're going to narrow down where our problem is. So we solved one of the problems. All right, if we don't normalize them, then we're getting nothing. That's extra strange. Okay. So what we cut out was this call as direction is equal to normalize of direction. Direction is defined up here outside of the if. It could be within this if, which would be also okay, but... Okay, if instead of this, we are going to take that one out. That is equal to this. Actually, let's do that first. So we are removing the part of the logic where we're creating integers out of that. And instead we're going in and saying like, okay, generate them as if they were floats. Still a bunch of zeros if we don't normalize them. Still really looking like there is a data structure error happening. As in, the format of the vectors that is coming back has some issues. And our vectors should be full of nada numbers now. Real quickly. Okay. Tricky, tricky. Tricky indeed. But what to do? I think we need to step away for a moment. I think that's going to be the gambit here. Buttons. And buttons. So we've made some progress, but now there's something about the shader and how it's emitting the array data back that is not lining up properly. There might be some further stuff we can do to narrow this down. But we'll have to see, because at the moment, I feel like I'm just spinning my tires. But progress. Okay, we fixed the access violation by switching over to arrays, and the data structure for that, in general, is in place. It should be okay. We just have to solve this not a number thing now. Should be interesting. But with that said, folks, I hope you had a good time watching with us tonight. I want to thank the pair of raids we had. Let me get it identified here. Alkaline and Lunas VT. I want to thank those folks for the raids and everybody that came with them. Wish YouTube made it as easy to do that, but I can tell you it's like jumping through hoops to actually set it up. It's much in the way that you have to schedule more diligently to create a YouTube stream with like a time frame. You have to do the same thing with the raid into kind of logic. But anyway, once again, I do hope you had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those buttons are generally good, so I'd appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means, as well as other options available through the link tree that can be found in my bio and video descriptions. And with that, folks, I hope you have a good rest of your day, and I'll see you next time.